In this lesson, we're going to look at estimating the roots of numbers. We're going to estimate square roots, cube roots, and then we just come up with some general rules for estimating roots. So, estimating square roots, we're going to first identify the closest perfect square less than or greater than the number under the square root sign. So, here, we're going to look at the lowest perfect square. So we have 12 right here. We have 12. We're going to look at the perfect square less than, which is 9, and then perfect square greater than, which is 16. Now we're going to now find the square root of the perfect squares. So square root of 9, square root of 16, and then we have the square root of 12 right here. So the square root of 9 is 3, the square root of 16 is 4. So now we're going to start off with the lower square root, so it's going to be 3. Now we're going to estimate the distance between, because we're going to end up with a fraction because it's not a perfect square, we're going to estimate the distance between the lower and the number we're interested in and the lower and the higher perfect square. So the distance between the lower perfect square and the higher perfect square is 7. So that's going to be our denominator. And the distance between our number, which is 9, and the lower perfect square, which is 9, and the number we're interested in, which is 12, is going to be the numerator. So this is going to be the estimate of what the square root of 12 should be. Now we can convert this to a decimal. 3 over 7, 3, 7, 32. So this is going to give us 4, 14. It's going to give us 2, and then 6 will give us 8. So we can say this is going to be approximately 3.428. So that's just an approximation. The next one we're going to look at is the square root of 47. So let's have our 47 right here. The lower perfect square is going to be 36. The greater perfect square is going to be 49. So we now have the square root of 36, square root of 47, square root of 49. So this is going to give us 6 over here. Square root of 47 is what we're interested in, and square root of 49 is 7. We're going to start with the lower square root, which is 6. Now we're going to estimate the distance between the lower perfect square and our number, which is 36 and 47. That should give us 11. And the lower perfect square and the higher perfect square, which is going to give us 49 minus 16, which is 13. Now we're going to just estimate the fraction, convert to a decimal. 11, 13. So we have 8. This is 104. 6, which is 4. 52. 8, 6, 1. So this is going to be approximately, the estimate is going to be 6.846. So that's just a general estimate of what it should be. Now let's look at the square root of 125. So we have 125. Our lower perfect square is 121. Our higher perfect square is 144. So we find the square root of 121 is going to be 11. Then we have square root of 125, and then we have 12, which is the square root here. Now we're going to pick the lower square root, which is 11. Now let's look at the distance from 121 to 125, gives us 4. And then the distance from 121 to 144 is 23. So now we're going to convert that to a decimal. This is 423, 0 point, put a 0 here, 1, 23, this gives us 17, and then we put a 0 here, this gives us 161 for 7, gives us 9, bring a 0 here, put a 3, 69, 21, and this is going to give us, put a 0 here, it's going to give us a 9 over here. So this is going to be approximately 11.174 as the square root of 125. Now let's look at the cube root here. So we have 16. The cube root is going to be, the lower cube root is going to be 8. The greater cube root is going to be 27. The cube root of 8 is 2. The cube root of 27 is 3. And then we have cube root of 16. So we're going to start with 2, which is the lower cube here. And then we're going to estimate the distance between 8 and 16, which gives us 8. 8 and 27 gives us 19. So let's convert 8 over 19 to a decimal, 0.80. So that gives us 476, gives us 4 here, bring a 0 down here, 2, 38, 2, put a 0 here, and then 1. So this is going to be 2.421 as the approximate cube root of 16. Let's also look at the cube root of 81. So we have 81, the lower cube root is going to be 64, and the greater cube root is going to be 125. So cube root of 64 is 4, cube root of 125 is 5, and then we have this right here. So it's going to be 4, and then the distance between 64 and 125, 61, and then 64 and 81 is 17. And then we will now convert to a decimal, the fraction to a decimal. 17, 61, 0 point, put a 0 here, we got 2, 122, 48, you bring down a 0, and we have a 7 here. This is going to give us 427. This is 5, 3. We bring a 0 here, should give us 8. It's 488. This is going to give us, bring a 0 here, it's going to give us a 6, 366. And this is going to give us 54. We can keep going, but it's 4.279 is going to be the estimate of this, of the cube root of 81. Now we're going to look at how do we generally estimate roots. So we've looked at square root, we're going to look at cube root. The method applies. So we're going to always look for the exponent. What I mean by that is a cube root is x times x, rather a cube is x times x times x. Cube root is, okay. So now when I say the perfect exponent, so let's look at 27 as an example, and we're looking at the fourth power or the fourth root. So we look at the lower number here is going to be 16, because 2 to the power of 4 is 16, 3 to the power of 4 is 81. So the fourth root of 16 is 2. Then we're dealing with the fourth root of 27, and then the fourth root of 81 is 3. Now we're going to have 2 as our whole number, and then we're going to have a numerator and denominator. 81 minus 16 is 65, and then 27 minus 16 is 11. Let's convert this to a decimal. So 0. This is 1, 4, 5, 0. This is going to give us 6, which is 390. 60 here. This is going to give us 9. And then 15, yeah. So this is going to give us approximately 2.169 as the fourth root of 27.